Welcome. All right, so we're going to look at conditional statements here. I want you to be able to analyze statements in if-then form, which means you're going to be able to give me, say, to look at conditional statements and converse, contrapositive. There's a lot of vocabulary here to help us understand proofing. All right, so moving on. So, a conditional statement is a statement that can be written in if-then form. For example, if you would like to speak to a representative, then press 0. Now, okay, so that, notice here, the if is like, is just, well, there's the if part, and then comma, the then part. Some statements can be rewritten in if-then form. Okay, so keep in mind, if-then statements are in the form of if P, then Q. Okay, so we're saying P is called a hypothesis, and then Q is called a conclusion. So basically, an if-then statement basically says we have an hypothesis, comma, conclusion. All right? Okay, so here is an if-then statement. If the forecast is rain, comma, then I will take an umbrella. Now, in any if-then statement, we can divide those into what's called a hypothesis and a conclusion. So again, the if part is the hypothesis, and the then part is the conclusion. Okay? Here's another example. Okay, in this example, I don't go if da la la la, then da 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 da. I say a number is divisible by 10 if its last digit is 0. So keep in mind, it's always easy to find it. If you find the if, that's going to be your P. That's going to be your hypothesis. Okay, and then the other part of that would have to be the conclusion. So in other words, this could have been rewritten as if a number's last digit is 0, then it is divisible by 10. See how that works? Okay, so for these, we're going to write them in if-then form. A mammal is a warm-blooded animal. Okay, so what does this mean? It means, and you kind of sometimes think about it. You can't just say if a mammal is warm-blooded, then it is an animal. Well, that doesn't work. But we can go the other way. If we know it's a mammal, so if an animal is a mammal, keep in mind there's other types of animals like dolphins and sharks. Those are not, well, dolphins are mammals. Sharks, though, aren't. Anyways, whole different story. Then it is warm-blooded. So then the mammal would be warm-blooded. See how that works? So we kind of established which one has to become our hypothesis that allows us to prove or see something as a conditional. Don't really have too many other examples because the book gave me all sorts of weird ones. Oh, I guess I did have more examples. Anyways, the sum of measures of two supplementary angles is 180. So here's one that's about geometry. Imagine that. Okay, so if I know two angles are supplementary, if two angles are supplementary, then the sum of the measures has to be 180. So you kind of see how that works. We're saying, okay, if something is supplementary by definition, then we are going to say it adds up to 180. The two angles would add up to 180. So that kind of gives you an idea. And again, keep in mind, you have to be able to identify the hypothesis, and you need to be able to identify the conditional. All right, you might want to copy down this truth table. If, so in other words, the hypothesis is true, and the then statement is true, then the conditional statement is true. Notice here that the only way you can get a false statement is if the hypothesis is true, but the conclusion is false, and thus that makes the statement false. That's very important to know. Okay, so here we're going to determine the truth value. If false, provide a counterexample. This is the one I only have really one example because for some reason they just didn't give me better ones. If you divide an integer by another integer, then the answer is an integer. Okay, so is that true every time? I mean, okay, so here's the thing. We assume this part is true, so we're dividing an integer by an integer, okay? Then we need to decide, is this part going to be true? Well, that's false because I can come up with an example saying 5 divided by 2 is not going to give me an integer. 5 and 2 are both integers, but 5 divided by 2 is like 2.5 or 5 halves. So not an integer, so that's why this is false. We'll look at more of those in an assignment, trust me. Okay, here's some related conditionals. You have your normal conditional statement, if P then Q. You have a converse statement. A converse statement switches the two. So basically, instead of saying, like now it becomes Q then P, like if Q then P, okay? And again, we'll maybe get a chance to look at some of those examples. An inverse basically makes them both negative, negates them both, so basically like, no, this is not going to happen, and no, that's not going to happen, that type of thing. Negative P, if negative P, then negative Q. And a contrapositive just basically switches the converse and makes them negative also. If you want to see better definitions for that, look at page 109 and you'll be able to get those. A conditional statement and its contrapositive are either both true or both false. Okay, so that kind of helps to know. Statements with the same truth values are considered to be logically equivalent. P if and only if Q, or sometimes written as P IFF Q, which means if and only if. That's just mathematician's shorter way of writing it, okay? So, and then one last part I want to cover is a biconditional statement is the conjunction of a conditional statement and its converse. Okay, so basically, I don't know how I messed up that somehow, but I was on the wrong page. So kind of keep in mind a conditional statement, both truth values are logically equivalent. How I lost the Y, I have no idea. Okay, anyways, a biconditional statement, which is where the if and only if is supposed to be. I was like just reading, I'm like going, that didn't sound right. Anyways, a biconditional statement is the conjunction of a conditional and its converse. It is usually written in P if and only if Q, or P IFF Q. So keep in mind, like we can have what's called a biconditional statement. Okay, for example, an angle is a right angle if and only if its measure is 90 degrees. So here's how this works, okay? So I am saying here that I have a conditional statement. I'm just going to put here conditional. And that conditional statement is saying if an angle is a right angle, then its measure is 90 degrees. Or 90 is 90. Okay? The contrapositive, let's do that one in a different color, shall we? The contrapositive, basically states, I should have put little semicolons here, that if an angle is right, wow, that didn't work out well. And if an angle is right, let me rephrase that. If an angle measures 90, then it is a right angle. Okay, so you see how those kind of work, and they're both true in both statements. So then this biconditional statement is true. Okay, but you kind of need to separate a conditional and a contrapositive to kind of see that. Anyways, I'll go ahead and stop there, and that's it for today. Thank you so much for your time, and let's look forward to, trying to work this stuff and making your head really think. All right, y'all take care.